In this video we're going to approximate the inverse hyperbolic sine function using the CORDIC algorithm. Now the process here is very similar to the previous video when we generated the inverse hyperbolic cosine function. We're going to have 4 steps that we work through. We're going to start off with an identity. Now this identity is very similar to the identity for the cosine. The only difference is that we've got a +1 here rather than a -1. So we note that the identity is arc sin x is equal to the natural log of x plus the square root of x squared plus 1. So in order to generate this x squared plus 1, the step 1 is a circular vectoring mode. Now in the circular vectoring mode, the output xn is equal to an, the square root of x naught squared plus y naught squared. So this gives us a way of generating this x squared plus 1. We can set the x naught is equal to 1. The y naught can be set to our input. Now in this instance here, the input we're going to use is 0.5. So what we're trying to do is find the inverse hyperbolic sine of 0.5. Now in this case here, the xn will equal an, the root of a squared minus 1. Now note here, because we're using the circling vector mode, the value for our scaling factor an, remember, is approximately 1.64676. So we set the value of y0 to the value 0.5, which is our input. The value x0 is set at 1. So the final output xn will give us 1.8411. Now we're going to have to divide this by the factor of an, and we're also going to have to add on the factor of a, which in effect is just this x here. So we're going to use the same process as we did in the previous video. It's going to be the division algorithm, and we're going to divide by the an, which is the 1.64676, and the value for our y naught is going to be the output from step 1, which is 1.8411. And the value for our z naught is going to be our input here, which is just our 0.5. So we're going to have the output zn is equal to a plus the root of a squared plus 1. So the a is the 0.5. So when we put that in, we get 0.5 plus the root of 0.5 squared plus 1. So we should get a value of 1.61803. So that's us worked out this section here. Now we have to go through and work out the natural log of this, and that is done in steps 3 and 4. So in steps 3, we use the hyperbolic vectoring mode. We set our x0 to a plus 1, y0 to a minus 1. And remember, our value for our a now is the output from the previous stage, which is 1.61803, and our z0 is equal to 0. So we're going to then generate the function here, which will be a half of the natural log of this value, which will give us a value of 0.24060, which in effect will equal an angle of 13.7854 degrees. So let's go to the final stage. Now in the final stage, again, we're going to have to multiply by 2, but we do this via the division algorithm, which is the linear vectoring mode, and we just divide by a value of 0.5, which is equivalent to multiplying by 2. So in this case here, we have our value for x0 is equal to 0.5, our y0 is just the output from the previous stage, which is 0.24060, and we have the 0 here for our initial angle z. So we're going to have this divided by this, which will give us 0.4812. So this should be the final answer, and it should be equivalent to the arc sin of 0.5. And if you check the arc sin of 0.5, you get 0.4812. So now what we want to do is actually generate this within the graphical calculator. So let's go ahead and we'll do that now. So this is our inverse hyperbolic sine function. And this is equivalent to the natural log of x plus the square root of x squared plus 1. So if I plot this value in, it's exactly the same. So this is really just to show that the arc sin x does indeed equal the natural log of x plus the square root of x squared plus 1. Now there's one point that we're going to be interested in, and it's the point we're going to use as an example, and that's the value 0.5. So if we put the value 0.5 in, we should get the output 0.481. So let's go ahead and we'll have a look at the 4 steps in order to generate this point 0.481. So in step 1 we're using circular vectoring mode. The value for our x0 is 1 and the value for our y0 is our input 0.5. Now again we're using vectoring mode, so we're going to add and subtract on and off the angles in order to ensure that this value for our y tends towards 0. So let's go ahead and we'll do that now. So you can see our final answer is 1.8407. And we can compare that to what we expect to get. So we expect to get 1.8411. So we're very close. So let's move on to the next step. Now the next 3 stages are the same as the previous video, so we're not going to work through them in full detail. We'll just give you the final results. So we're in step 2, we're dividing by our value an, and we're adding our factor of a on. Now, whenever we work through this, we should get a value 1.61803. We in fact get a value of 1.6211. Again, I'll note these on the separate page at the end of the video, and you'll see these comparisons. And these are the angles that we used in order to generate the final value for our Zn. Now we start working out the natural logarithm. Again, we're using the hyperbolic vectoring mode, and the result we expect to see is 13.7854 degrees. Now, whenever we work through the simulation, these are the angles which we'll add on and subtract, and the final angle we get is 13.9002 degrees. Now in the final step we have to multiply by 2, and whenever we work through this final step we expect to get a value of 0.4812 for our final answer. So the final answer we get is actually in degrees, so it's this angle here, which is 27.97 degrees, and that gives us a value of 0.4882. So we're relatively close. Now what we'll do is we'll go and we'll summarise the actual values, and you can see the calculated results against the simulated results. So these are the calculated and the simulated results for each of the steps, and you can see that the final value here we expect for the inverse hyperbolic sine of 0.5 is 0.4812, and the value we get after our simulation is 0.4883. So let's go ahead and we'll plot these. So this is our inverse hyperbolic sine function. For 0.5 we expect to get 0.481, and from our simulation we got a value of 0.488. So this is our expected result, and this is our simulated result. So that's us finished with the 2 most difficult values, functions that we want to try and approximate, that is the inverse hyperbolic sine and inverse hyperbolic cosine. So that's all for this video. Thank you for listening. I'll get you in the next video. Goodbye.